The American, Graham Bell, invented not only the landline telephone, but even a phototelephone which transmitted speech by means of light signals. Those experiments led to the idea that optical glass fiber could be used for communication. Transmission medium of the future, replacing all kinds of earlier wire communication. An optical fiber, thinner than a hair, can carry thousands of separate telephone conversations. Instead of passing electric current through a wire, signals are transmitted by laser, or LED, and carried by a fiber. The production of fiber demands skilled labor and well-qualified technical staff. High precision is called for at every stage, necessitating a clean room environment. Ericsson Cables has its production of preforms, from which the fiber is drawn. The preform is a glass rod, about 1 meter long, made from very pure but specially doped silica. Two types of fiber are made, a single-mode type for long-distance use and high transmission capacity, and a multimode fiber, less demanding in use and suitable for shorter distances. We shall now show how a single-mode fiber is drawn from a preform. The preform is placed at the top of a 12-meter-high drawing tower. From the preform, up to 40 kilometers of fiber can be drawn, which means about 500 meters from every preform centimeter. The preform is lowered into a furnace. It must be absolutely vertical and be placed centrally. The tip of the preform is heated to around 2000 degrees. After some minutes, the tip softens and moves down from the preform, drawing a glass fiber after it. The drop emerges from the furnace underside. The glass drop is removed and the trailing fiber hand-drawn until its diameter is near 125 micrometers. The fiber is threaded through a coating cup where a layer of soft acrylate is applied to protect it. A layer of harder acrylate is then applied over the soft inner layer, making the fiber more durable. To check that the acrylate is being applied concentrically about the fiber, a beam of laser light is shown through the fiber, and the forward scattering pattern, which should deflect symmetrically, is observed. The coated fiber is irradiated with UV light to cure the acrylate layers. The fiber, now protected by two coats of acrylate, primary protection, passes through a series of sheaves on its way to the take-up spool. A computer controls the whole process together with the machine operator. Certain parameters such as fiber diameter are recorded continuously so that the high quality associated with Ericsson cables is maintained. No fiber leaves the factory without having undergone thorough testing. The tests include mechanical and optical properties. The results are then documented. All data accompanies the fiber when it is sold. During the proof test, the fiber is subjected to a predetermined stress throughout its entire length. The fiber passes twice around a capstan wheel, which has two different diameters. This produces a tension in the fiber, which is checked with a load cell. With this instrument, laser light pulses are passed into the fiber, and the attenuation through each part of the fiber is noted. A fiber shearing machine is used to expose an even cross-section of fiber. Under a microscope, the concentricity, diameter, and circularity of the core is checked. One 1,000 millimeter variation is the maximum allowed. This apparatus measures the chromatic dispersion, a measure of how much a single pulse broadens in time on its way through the fiber. The light has to be carefully focused and well defined, especially for long lengths of fiber. After testing, the fiber is sent for secondary coating. The lifetime of an individual fiber is calculated to be at least 40 years. So the testing is as important for the customer as it is for the manufacturer. Both must know that the optical fiber from Ericsson cables is of highest quality.